Hello, this is Jason, and I wanted to give a quick demo of the Smart Player Piano. It's a little program I developed a couple years ago for my senior design project at the University of Cincinnati for a computer science bachelor's degree. So what this program is if you've heard of player piano, we'll do a little bit of background first. A player piano is basically a real piano that has the added functionality of taking scrolls, or I guess they paper, or in rare instances metallic rolls. They're sheets of paper that have holes in them, and there's a vacuum in the piano that detects where these holes are in the sheet of paper. And the further right the holes are, the higher the note, and the further left the holes are, the lower the note. So I'll get a little more. Here's some pictures of the rolls, old songs, and this is the type of mechanism that it gets put into. You can see where those little dots you see in the center, those are vacuums detect where the holes are. And here's a quick video I found of a demo. So you load it in, you wind it up, and then sometimes there's pedals at the bottom, and you can see the piece of paper moving down. And then as holes go by, then the piano starts to play the notes. So most people have seen this before, just may not have realized what it was. So, okay, so enough of the background there. Go back to the project that I worked on. And so the idea of this project was a couple layers. So the first layer is I wanted to be able to take create a player piano roll of my own by drawing and see what just be able to draw different songs. So this is the Smart Player Piano. I have a pen selected right now, so I can just go ahead and draw a bunch of different notes. I can draw a smiley face if that's what was wanted. There you go. And so you'll be able to see this. It's just like the piece of paper. The further left, these are low notes. Further right, these are higher notes. We'll give it a play. And so you can see this blue line here. That is the threshold for when the dot passes that, it plays that note. So you're kind of on two axes here. X-axis is the pitch of the note, and the y-axis is the time of the note. Yeah. So that was the first goal. I wanted to be able to draw a picture, be able to draw notes, and see how they worked. So you can see this little thumbnail of what the image looks like, because these are all just pixels here. And so then another goal was then to be able to import MIDI files and see what they would look like on a piano roll. So we'll start fresh here and go ahead and open up. Apologize for the slowness. My computer is a little bit slow, and it doesn't like recording the screen at the same time. So got a bunch of different songs here. One of my favorites is Take Me Out to the Ball Game here. So these are just random MIDI files I downloaded from the internet. And what it's doing is it is opening up that MIDI file, going through the entire file, and marking where each of those notes would be based on those two axes, the x-axis for the pitch and the y-axis for the time. And you can see one thing I didn't show you before is the line here. A line, if it's a continuous line, of course, that note is going to stay continuously played. So here's Take Me Out to the Ball Game. Alright, Alright, and so you can kind of see, you can hear some higher notes over on the right side, some lower notes down here on the left side. Okay, and all's fine and dandy there. So some of the other fun things that wanted to be able then to do is I said, okay, well I can take any MIDI and open it up. We'll just demo one more real quick. How about Flight of the Bumblebee? Everybody knows that one of some sorts. And this time I'll also demonstrate the tempo marking here as well. You can just modify the tempo of the song as it goes. And then this vertical squish over here, I guess it should really be called, oh no, vertical, yeah, that's the right way to go. So it's, it'll shorten, basically shorten the y-axis. So you guys see these numbers on the side, I believe those are seconds, so 15 seconds. Oh, I guess it's more than that. So, oh, it's ticks and minutes, that's what it is. So, Flight of the Bumblebee here, everybody knows that should be faster, so let's go ahead and increase the tempo a little bit. Great. And so we can also slow it way down. Fun. Okay, but that was only the second part. So after that, the first part was being able to draw. Second part, being able to import songs that were already created to see what they would look like on a piano roll. But what if you wanted to see, or hear rather, what some image looked like? Say the Mona Lisa, or a picture of yourself, or something of the sorts. What if you wanted to hear what your face sounded like? So, went ahead and did something of that sort. I have just a couple different images here, and what this is going to do is that it's going to import this image, and it will then do an edge detection algorithm on it and only print out the pixels that kind of do its outline. So in University of Cincinnati spirit, let's do a CPAL. So it takes that image, detects the edges, and voila. So you can see the full image over here. And here's all our pixels here. So we can hear what the University of Cincinnati CPAL sounds like. So I'll give you a little spoiler alert here that it's going to sound pretty terrible because obviously there's lots of notes really close together, both on both axes, the X and the Y. So a lot of notes that it's basically going to sound like someone is just kind of banging their hands on the piano a little bit. So here it is. Lovely, right? So that fulfills that requirement, but it kind of falls short a little bit. So this is where the smart and smart player piano comes in. I wanted to be able to then take it one step further and modify the image so that it still kept its basic shape. You could still see that it's a CPAL, but I wanted it to sound good. So I wanted to move the notes that don't belong, or remove notes that don't belong, but only the notes that don't belong. So using a little bit of basic music theory, chord progression principles, implemented the autofix. So we'll go ahead and give that a click, and it's going to modify a lot. So you can see on this side here, it looks pretty different, but if you look at the image as a whole, you can definitely still see the CPAL, and we'll give this a listen. Right, so it sounds a whole lot better. So let's go ahead and give another example real quick. I gave the Mona Lisa as an example earlier, so we'll go ahead and put her in there. So we can hear how Mona sounds. And I'll give you a hint. Just like the C-Paw first, she does not sound very good. Alright, so we got Mona here. We'll give her a play. Right, so she sounds a lot like the C-Paw at first. So I'll give the auto fix a go here, and again what it's doing is it is moving these little dots here left and right, because left means lower, right means higher pitch, and it is modifying them so that the notes are in the right place to make a sound that's decent to the human ear. So over here we got our thumbnail, and you can still see she's quite a bit different, but you can still definitely pick out Mona in there. So let's give her a listen. Great. So that about does it. Pretty quick demo of what the program does. There's a few other features here and there, but that pretty much covers the main points. If you're interested, head over to my website at www.pwlk.net, and I've posted the program there to download with some further descriptions and pictures and such. So that's about it. Have a good night.